So AI agents are getting insanely powerful, right? But that brings up a huge question. How do we keep them safe? Today, we're going to dive into NVIDIA's answer to that problem, a system they call NemoClaw, which is all about putting these powerful AIs into a secure digital sandbox. I mean, think about it. These AI agents can already do just about anything. They can write code, they can manage entire systems, they can pretty much operate on their own. But all that amazing power comes with a really critical question. What happens if they mess up? Or even worse, what if somebody with bad intentions gets a hold of one?
And that right there is the big dilemma, isn't it? The very same autonomy that makes these agents so incredibly useful is also the exact thing that makes them potentially dangerous. So let's break down what those dangers actually look like.
So what are we really talking about here? It's not just some abstract fear. We're talking about serious, concrete risks. You've got data leakage, where an agent could accidentally or maliciously spill sensitive info. It could be tricked into executing malicious code, basically opening a backdoor into your system. It might just take unintended actions, like deleting a critical database because of a misunderstanding. And then there's prompt injection. That's a scary one. That's where a clever attacker can essentially hijack the agent and make it do whatever they want. So it all boils down to this. You just can't deploy something this powerful if you can't control it. For most companies, for most developers, the risk of an autonomous agent just running wild on their systems is way, way too high. That's the problem that absolutely has to be solved. Okay, so we've laid out the problem. Now, what's the solution? Well, that's where NVIDIA comes in. They've been laser focused on this, and their answer is a framework called NemoClaw. So what is NemoClaw, really? At its heart, it's a plugin for an open source framework called OpenClaw. And its whole job, its entire reason for being, is to take that AI agent and stick it inside a tightly controlled environment, a sandbox where every single thing it tries to do gets checked against a strict set of rules.
Honestly, the best way to picture this is like a secure playground for your AI. The agent gets to run around, do its thing, perform all its tasks, but it absolutely cannot leave the playground, and it can't touch anything that's not allowed by the rules you've set up.
All right, so this secure playground idea sounds great, but how does it actually work? What's going on under the hood that makes this whole thing possible? Let's take a look at the architecture. Now, this part is actually pretty brilliant. NVIDIA split the design into two parts. You've got the plugin and you've got the blueprint. The plugin, that's what you interact with. It's small, it's stable, it doesn't change much. But the blueprint, that's where all the heavy lifting happens, all the complex security logic. And this is so smart because NVIDIA can constantly push critical security updates to the blueprint, and you, the developer, don't have to change a thing. It just works. And building that sandbox is a nice, clean, three-step process. First, the plugin grabs the blueprint and verifies it, making sure it's the authentic, untampered with version. Then, the blueprint itself figures out exactly what needs to be built or updated. And finally, it makes the call to another tool, the OpenShell CLI, to actually construct the secure sandbox. It's simple, it's secure, and it's all automated. Now, this sandbox isn't just some simple container. It's built like a fortress with 4 distinct layers of protection, all powered by NVIDIA's OpenShell technology. Let's break down each one. This table gives us a fantastic snapshot. You see the 4 layers: file system, network, process, and inference. But check out that last column. See where it says hot reloadable for network and inference? That's a game changer. It means you can literally update the security rules on the fly while the agent is still running. No restarts, no downtime. That is a seriously powerful feature. Let's dig into layer 1, the file system. This is super straightforward but incredibly effective. The AI agent is only allowed to write files in 2 very specific folders. Everywhere else on your computer's drive, strictly read-only. That completely stops it from messing with your system files. Okay, layer 2 is all about the network, and NemoClaw takes a default deny approach here, which is exactly what you want. If the agent tries to connect to some website or API that's not on its pre-approved list, that request gets blocked flat out. A human operator then gets a notification and has to manually sign off on it. This keeps a human in the loop for any new connections. Layer 3 gets really deep, down to the kernel level of the operating system. And this is crucial because this is the deepest, most fundamental level of control. It makes it practically impossible for the agent to escalate his privileges to become an admin or make any dangerous system calls that could harm the host machine. And this last layer, this is one I bet you didn't see coming: inference control. Even when the agent tries to talk to its own brain, the large language model, those requests are intercepted. This makes sure it's only thinking with an AI model you've approved and not trying to secretly route its queries to some malicious or untrusted model out on the web.
And when it comes to those approved models, you've got options, which is great. You can hook it up to NVIDIA's super powerful cloud models for maximum performance, run it against a local service on your own network for more privacy, or even use a completely offline model for development. You're not locked in.
Okay, so we've gone through all the technical details, the 4 layers, the whole shebang. So what's the big takeaway here? Why does all of this really matter?
It all comes back to one word: confidence. This whole sandbox approach gives developers the confidence to innovate, to experiment, to really push the boundaries with powerful AI, without having to worry about putting their own systems or data at risk. It's about letting you harness the full power of these agents, but within a framework of clear, verifiable security rules.
And you know, this quote from the NVIDIA documentation just nails it. The whole goal is to give you a fully working, incredibly powerful AI agent, but in a way that completely seals it off from your own machine. It's about enabling power through safety.
So at the end of the day, tools like NemoClaw are all about giving us the control we need to manage this incredible technology responsibly. And that leaves us with a really exciting question to think about. What are you going to build when AI is truly safe to explore?